Good evening, everyone. Welcome to O-level physics lesson. Today we'll start on the new topic on practical electricity. Okay, the most fun part of electricity is the last topic, where you solve a lot of problems. Okay, this topic is also equally fun. Okay, equally fun, but I think last topic is more fun. Okay, today is Tuesday, 14th of June. After today, half of June is over. And half your holiday is also over as well. My name is Mr. Chu. Let's begin. Okay, so I've asked a check-in question. I asked two check-in questions to ask you about the formula for power. That is what you have learned in last year. Okay, the power that you learned last year. Okay, not the one that you learned this year. Okay, so Ryan got it correct. Well done. Ohm's law. Ryan got both correct. Very good. Yuting, your power is not wrong. It's what you are going to learn this topic. I'm asking for the last year topic, but it's okay. Yuting, both your answer is correct. Same for Oscar, your power is based on this topic, which is fine. Oscar, your Ohm's law is correct as well. Okay, Qiao Xing, can you tell me what does Q stands for? Your Q, what does it stand for? And then what's your Ohm's law, the formula for Ohm's law? And for Pei Kwan, well done. Very, very good. Okay, so let me just recap what we learned last year. Okay, last year we learned this formula. Power is energy over time or work done over time. Okay, this is what we learned last year. Okay, and then we're going to go through this year as well. Okay, Qiao Xing, energy is not Q. Q represent charge. Okay, not energy. Okay, so don't use Q, use E. Okay. Okay, so this is what you learned last year. So power, the meaning of power is the rate, okay, of work done or the rate that energy is used. Basically, how much energy is used every second. So the greater the power, it means that you uses much more energy every second compared to something else that's less powerful. Okay so far? Then for Ohm's law, that most of you got it correct. Okay, there's one of you that haven't given me the answer. Okay, who's the last student? Who haven't given me the answer yet? Ryan. Oh, Ryan given me just now. Sorry, Ryan's the first to give me. sorry. How Ray, where is your answer? How Ray? How Ray, that's your formula for Ohm's law. How about the formula for power? What is your formula for power? Okay, very good. Okay, so for Ohm's law, okay, basically it's R equal to V over I. Okay, but what I always teach my student, the way to remember this formula is just V equal to Ri. Okay, if you all forgot, the way to remember this will be victory equal to Raffles Institution. Okay, it's still in my head because that's how my teacher teach me. If you think it's useful, you can also remember this. Okay, so far? Okay, so V equal to Ri. In a lot of textbook, they will not show you V equal to Ri. In a lot of textbook, they will show you V equal to IR. Okay, but for secondary school physics, right, they are all the same. Okay, any question before I continue? Okay, you are clear about this? Okay, let's continue. Hold on. Okay, I'm going to show you what I always show you at the start of all topics. Okay, take a look at this. Okay, as you can see, we are now at the last branch, which is electricity and magnetism. So I've gone through charges, electrical charges that's not moving. We'll talk about electrical charges that's moving and how they can actually form circuits that's useful for everyday life. Okay, and then today we're going to talk about practical electricity. Okay, once we are done with practical electricity, we are done with the pure electricity topics. Then we talk about magnetism, and then we link the electricity and magnetism together in the last two topics. Okay, so this is a whole overview of how physics is you need to learn in O level. Okay, so we are actually finishing. We are now at practical electricity, and we're going to finish very, very soon. Okay, so next, I'm going to show you all the syllabus. Okay, so for practical electricity, as you can see here, is broken up into three parts. The last two parts, okay, the last two parts are a lot of factual stuff with some common sense. Okay, so the last two parts, you need to actually read up your textbook, read up your notes. Okay, so I will not cover the last two parts much. Okay, because they are all facts, just like electromagnetic spectrum is all memory stuff. Okay, the interesting part about this topic would be the first one, which is electrical power and energy. Okay, so far? Okay, so for this topic, what are you expected to know? Okay, you all need to know, number one, how electricity can be converted to heat energy or thermal energy and is used in kettle, oven, and heater. Okay, so this one, when we go through some example, okay, I will show you some example later on. Okay, so this is one of the first things that you need to know. Okay, number two, this is something that all of you, I've gone through this a few times the last few lessons. Okay, but this thing is actually introduced only in this topic. Okay, so the new thing that you're going to learn in this topic and the only formula that you need to learn in this topic is this formula. Okay, power is a product of the PD and the current going through the load. I repeat again. Okay, power is a product of the potential difference and the current passing through the electrical load. Okay, this is the formula that you need. Is something new that you learn today. Okay, learn in this topic. Okay, and where do you see power before? I mentioned earlier on. Previously, you learned in the topic of work, energy, and power. You learned that power is the work done over time or energy over time. Is that clear? Okay, so previously you have learned power is energy over time. Okay, so in this topic, to calculate a power of a component, of an electrical component, you just need to multiply the V and the I, and you're able to calculate the power. And once you know the power, okay, let me point you out to this formula. Once you know the power, okay, you all know this formula, right? Can we rearrange to make E the subject? You will get energy is equal to power times time. Okay? Okay, so the first formula that all of you need to memorize way back in chapter 6 or 7 is this formula. Power is energy over time. And the second formula that you all need to learn today will be power equal to V times I. And then from there, we can derive a lot of formula from these two formula. Okay, and then one more formula that all of you need to remember is that the Ohm's law formula, which is V3 equal to reference institute. Okay, so with these three formula, we will be able to come out with a lot of formula. Is that clear? Okay, so I want all of you to type out these three formula. Okay, which you all need to remember. Formula 1, Formula 2, and Formula 3. Okay, can all of you do that now? Okay, when I say this is because it is all very, very important. Okay, if it's very important, therefore, I want you all to remember these three formula. Because this topic, there are a lot of formula, but if you know these three formula, okay, if you know these three formula, you can derive all the other formulas. Is that clear? Yeah, I give you all about 1 minute to type out everything. Okay, I want you to type out the three formula. Only Qiao Xing and Yu Ting have given me the three formula. How about the rest of you? Qiao Xing, you did not give me the third formula. Okay, waiting for the rest of you. Okay, Hao Rei, Oscar, Ryan, your time it should be small letter, not big letter. Okay, Ryan, your T rewrite again. It should be small letter. Okay, well done, Ryan. How about the rest of you? Okay, Pei Kuan, well done. Okay, before I continue again, there's a lot of things I haven't shared with you all. Let me give you the unit. Okay, the unit. Okay, I'll write in black. So the unit for power is watt. Okay, the unit for power is watt. The unit for V is volt. And the unit for I is ampere. Okay, are you all clear about this? Okay, same thing for this. The unit for energy is joule. The unit for time is seconds. The SI unit of P in this case is watt. Okay, so if I rearrange, this will be joule, this will be watt, and this will be seconds. Clear? Okay, now same thing for this. This is in volt, this is in ohm, this is in ampere. Okay, so now I'm going to derive a lot of formulas. Okay, starting with this red formula that you need to learn. Okay, this red formula is something new. Okay, and from this red formula, you're able to come up with the rest. So let me write down the red formula first. Okay, we know that power hold on. Okay, first of all of you, can you please write this down? All of you, write this down. Okay, all of you write this down. Power is equal to VI. Okay, all of you know this. Okay, all of you type this, write it down in a piece of paper. Okay, the second thing is we also all know that energy is equal to power times time. Okay, let me rewrite. Okay, so now all of you know that power energy is equal to power times time. Correct? If I were to substitute the power here with VI, if I substitute the power here with VI, can we come out with this formula called energy is equal to VIT? Can we do that? Because the power, I replace the power with V times I, and therefore this formula will be energy equal to VIT. Okay, VIT. Can? Are you clear about this? Okay, so this is the first formula you need to derive from P equal to VI. So can you see in part B, there's the second formula here, E equal to VIT. Okay, this formula I did not highlight because all of you should be able to derive because you already know Formula 1 and Formula 2. So the last part here, this formula that all of you are expected to know, okay, can be derived from Formula 1 and Formula 2. Are you all clear about this? Okay, next thing. Look at Formula 3, Ohm's law. In questions, when the question asks you to find power or energy, either one, if they want to ask you to find energy, they give you time. Okay, in question, sometimes they don't give you the V and the I. Okay, sometimes they don't give you the V or the I. Sometimes they just give you something else. They give you R and I, okay, or V and R. Then how? Okay, are you able to calculate the power if they don't give you V and I, but they give you the R? So for example, you look at Formula 3. V is equal to Ri. If they don't give you the V, can I replace the V with Ri? And then I will get a new formula called Vp is equal to Ri squared. Can you see that? Okay, P is equal to Ri squared because the V can be replaced by Ri. So when V is replaced by Ri, you get Ri times I, you get Ri squared. So sometimes in exam, they will not give you the V and the I. They may give you R and I. Okay, so you need to be able to quickly use Formula 3, substitute into Formula 2 to give you this formula for you to do the question. Clear so far? Okay, these are things that you don't need to memorize, but you can derive yourself quickly. Okay, likewise, we know that energy is power times time. Can I also give you the same formula? VI is a power. Instead of VI, can I use RIT? Ri squared. So energy can be also the same as Ri squared times time. Is that clear? Okay, so all these formula that I write below, I do not expect you to memorize. If you want, I will stop you. Okay, but what I'm saying that with Formula 1, 2, and 3, you should be able to come up with all the other formulas. Okay, again, what happens if I is not given for you? If I is not given to you, right? You know that I is equal to V over R, correct? Yeah, rearrange to make I the subject. So what can I do? Can I still calculate the power if you are given only the voltage and the resistance? I repeat myself again. Can you still find the power, okay, if I just give you the voltage and the resistance? Okay, yes, you can. This I can be replaced by V over R. Can you see here? So therefore, your power is also the same as V squared over R. Is that clear? Because your I is replaced by V over R. So you'll get V times V over R, you get V squared over R. Okay, so you can also calculate the power with this formula. These three formulas are all the same because you just manipulate between formula 2 and formula 3. Is that okay? Same thing. Energy is equal to power times time. Okay, you will use the power, which is V squared over R, and then you multiply by time. So you get V squared T over R. Okay, so all the rate formula below, if you understand how to derive them by yourself, give me a thumbs up reaction. Okay, if you are clear, give me a thumbs up reaction. Okay, so now that all of you are clear, can you type out the 6 formula, the 3 power formula, and the 3 energy formula, and type it out onto your chat and show it to me. Okay, everybody, type out the 6 formula and show it to me. Okay, all of you type out the 6 formula, the 3 power and the 3 energy formula. Okay, and show it to me. Okay, Xiao Xing, well done. Ryan, well done. Yu Ting, well done. Bei Kuan, your first energy formula is wrong. Can you try again? The rest are correct. Oscar, well done. Auri, well done. Okay, very, very good. Very good. I'm very happy. So you're able to derive yourself. This will be my checkout question. Okay, I'm going to ask you this as a checkout question. So you have been warned. Okay, so let me go back to the formula of power. Okay, so all of you know that power is, okay, in chapter 6 or 7, right? Power is energy over time. Okay, and therefore energy is equal to, okay, sorry, this one's wrong formula. Okay, power is energy over time. Okay, so all of you know that energy is power times time. Clear so far? And then I mentioned about the SI unit. The SI unit for power is watt and time is second. So the energy that is being used okay, that is being used by, regardless is it electrical appliances or anything that has energy. You just need to multiply power times time. And you can imagine this figure, energy, will be a very big, energy is joule. And this energy will be a very big number, okay? Will be a very big value. Okay, so when you want to calculate it at home, right now at home, if you can, next week, you go and ask your parents for your electrical bill. Okay, your electrical bill will be based on how much electrical energy is being used multiplied by the unit price. Okay, so for example, if your bill is going to show you your unit by joule, the figure is going to be very, very big. Okay, so for home and office, we do not use joule to show the unit for energy. Okay, I repeat myself again. Because if you use joule, the number will be very, very big. So instead, okay, for electrical bill, the bill that you see, you will not see the unit joule. You will use another unit called kilowatt hour. Clear so far? Okay, so what do you need to do? Okay, let me show you. What you need to do is instead of finding the watt multiply the number of time that is being used by your electrical appliances, okay, to make the number smaller, we use kilowatt. Okay, for the power part, we use kilowatt instead of watt. So your number becomes 1,000 times smaller. Is that clear? Then, instead of seconds, okay, we don't use minute, we use hour. Okay, we use hour. Okay, so for kilowatt hour, it is 1,000 times smaller. Your number will be 1,000 times smaller because this is about 1 kilowatt is the same as 1,000 watt. Okay, so 1 hour is the same as 3600 seconds. So your number, okay, when you look at your electrical bill, this 1 kilowatt hour, this figure will be 3.6 million times smaller compared to joule. Is that clear? Can you understand that? So in your electrical bill, the amount of electrical energy used will be based on kilowatt hour. Is that clear? So for example, 1 kilowatt hour is the same as 1,000 watt multiplied by 3600 seconds. So 1 kilowatt hour actually will give you 3600,000 joule, which is the same as 3.6 megajoule. Okay, so if you were to have a chance, ask your parents for your house electrical bill, you will know that you will actually notice that the bill comes in the unit of 1 kilowatt hour. And then you will see a cost. 1 kilowatt hour costs how much? Is that clear? Okay, so now I've calculated for you. 1 kilowatt hour is the same as 1,000 watt times 3600 seconds. So it'll give you 3.6 million joules. So 1 kilowatt hour is about 3.6 million joule. Is that clear? Are you okay? So do you know what a 3.6 million joule means? Are you able to appreciate what does 3.6 million joule means? Okay, how about like this? If you are at home, I give you 2 minutes. You go and ask your parents whether they have any of electrical bill to show you. Okay, if you have, okay, bring over here. Then we are going to talk about a bit of electrical bill as well. Or should I show you my electrical bill? Wow, my bill so expensive. Okay, maybe I show you my bill. Hold on. Okay, let me find my view. Okay, let me show you my view. Okay, can all of you see this view? Okay, we just look at the focus on one thing only. We look at electrical services. Can you see that? So can you see for the month, okay, I use about 226, okay, 226 kilowatt hour. Okay, and then you already know that 1 kilowatt hour is the same as, okay, 3.6 megajoule. And how much does Singapore Power charge me for every 1 kilowatt hour? Okay, it charged me about 28 cents. Okay, it charged me about 28 cents. Is that clear? Okay, and therefore, my electrical bill for the month will be $63. Okay, there are also other bills like gas services. I don't know why gas services is also in. Oh, right. Because gas is also in terms of energy. Therefore, this is the gas services. Okay, and this one is in cubic meter. Do you know what is cubic meter? Cubic meter means meter cube. So I use about 4.7 meter cube of water. Okay, so that is the unit for the water itself. So can you imagine what is 1 cubic meter? Imagine 1 meter by 1 meter by 1 meter. This is the same as a cube. That is 1 meter by 1 meter by 1 meter. So if it's a water that's filled up all the way, it will be 1 cubic meter. And 1 cubic meter of water is about 1,000 kg of mass. Okay, it actually has a mass of about 1,000 kg. Clear so far? Okay, so if you look at your electrical bill, the energy that for me I use is 226 kilowatt hour. So every 1 kilowatt hour, the SP services actually charge me about 28 cents. So I use 226 kilowatt hour, they charge me about $63. Is that clear? So how many of you have your electrical bill in front of you? It should be higher than mine, right? Mine should be considered low. Is that correct? How many of you have an electrical bill lesser than mine? Okay, raise your hand. Any one of you has an electrical bill less than mine? Raise your hand. Okay. So the next thing I'm going to revise with you is how big is this number? What does 3.6 megajoule means? Okay, so remember that energy is similar to work done. Work done is force multiplied by the displacement of the object. Is that clear? So for example, if I have a force, so 1 kilowatt hour means you have a force of 1 Newton, okay, pushing a box in one direction. Okay, so the work done of 3.6 million joule means you have 1 Newton of force pushing a box. You can actually push for 3.6 million meter. That's a very long distance. So that the work done will be 3.6 million joules. Okay, so I want you to appreciate 3.6 million joule is quite a big number. Is that clear? It's quite a big number. And our electricity costs 28 cents just to give us 3.6 million joule of energy. Okay, I use another example. If how much energy does it need to lift you up? Okay, to lift you up based on 3.6 million joules. Okay, I'll give you an example. Can all of you tell me your weight? All of you tell me your weight. Type it out in the chat. I look at the average, then I'll use an example to give you. Can you tell me your weight? Okay. I only 2% tell me. How about the rest of you? Wow, Beikwan, you're so small. Okay, I see a few common numbers. So for example, you tell me that your mass is 60 kg. So your weight is actually about 6,000 Newton. Am I right to say that? So if I want to lift you up, let's say this is you, this square is you. I want to lift you up. You all remember gravitational energy? Gravitational potential energy is mass times G times H. Okay, so this 3.6 megajoule can lift you up how much? Okay, can lift you up how much? So if this is 3.6 mega equal to, let's say your mass is 60 kg, G is 10, and then I have a H. Let me find my calculator. Okay, so let me just give you the answer. 3.6 million divided by 60 divided by 10. I can actually raise you up 6 kilometer I. Okay, so 1 kilowatt hour has enough energy to lift a 60 kilogram mass of you up 6 kilometers. Are you amazed? Are you amazed? Okay, and then how much energy does it cost you? Just 28 cents. Okay, so you pay 28 cents. I can actually bring you up 6 kilometers, almost two-thirds, almost three-quarters of, almost two-thirds of the height of Mount Everest. So 28 cents can bring you up so high. Okay, so can you imagine if I use 226 kilowatt hour, how much energy I actually use at home? Okay, so to reduce this value, okay, use less water heater, use less fridge, use less aircon. Okay, the two most energy consumption that you use at home are air conditioner and water heater. Okay, your bathing water heater. These two actually use up the most electricity at home. So if you all can control these two things, your usage will be much lower. But if you don't care, on your aircon the whole night, then when you go and bathe 2 hours, okay, definitely your bill will be very, very high. Is that clear? Ken? Do you all know why water heater use up a lot of energy? Have you all learned the topic, the thermal topic, where we calculate how much energy is needed to raise 1 kg of water by 1 degree Celsius? Do you remember the topic? Do you remember that every 1 kg of water to raise by 1 degree Celsius, we actually use a lot of energy? And then water heater heat up water very, very fast. So the energy used and the power used is very high. Okay, therefore, water heater as well as air conditioner use a lot of energy. Is that clear? So far, are you able to appreciate why you learn this topic? Now, are you able to relate to real life now? If you can relate, give me a clap. Howard, Ryan, and Chelsea, are you there? Okay. So now you all know about how much I use energy at home. Okay. You look at your electrical bill, I think yours should be much higher. Okay, so to help your parents save money, use less aircon, use less water heater. TV, computer also use that, but not as much as computer, not as much as aircon and water heater. Okay, so this is my view. Let's continue. Okay, so now I will talk about power. Energy is equal to power times time. And in this topic, your power is in kilowatt, your time is in hour, and therefore your energy use will be in kilowatt hour. Okay, all these three units are not the SI unit. Okay, what you learn in chapter 7, okay, the joule and the watt and the second, that is the SI unit. But because if you were to leave everything in SI unit, it will be a very, very big number. So therefore, we use kilowatt hour to represent how much, okay, energy you use, okay, for your electrical appliances at home or in office. Clear? So that is actually for part C. Now, the rest down here, I don't like to go through because they are all very factual. So can you please read through all of this in your textbook? Okay, because if I were to go through them, they will be the same as I read through from the textbook. So you don't need me to read to you the textbook. Okay, but one thing I would like to go through is this. Okay, one thing I go through is this. Just remember, okay, wait, before that, yeah. So all of these things, later on, I'll go through quickly. But if you can, please go through yourself. Okay, because they're all facts. Okay, so let me explain a bit more things here. Okay, safety devices, fuses, circuit breakers, all these are safety devices. Okay, so the thing that you must remember is that when you apply all these items, switches, fuses, and circuit breaker, they should all be at the live wire. Okay, they should be all at the live wire. Okay, not at the earth wire and not at the neutral wire. Okay, what do I mean by that? Okay, so for example, you all learn circuit. Okay, this is your appliances. To power your appliances, one of them will be live and one of them will be neutral. Neutral has a voltage of 0 volt or potential of 0 volt. Okay, in Singapore, live is 230 volt. Okay, so if it's 0 volt and you yourself is 0 volt, by right, if you touch a neutral wire and not any live wire, you should be fine. However, because the live wire has a potential of 230 volt and you yourself has a potential of 0, there's a difference in potential, current will flow. You remember that? So therefore, don't go and touch the live wire with a bare hand. Okay, so all the safety appliances like switches, fuses, and circuit breakers are all connected at the live wire. Okay, not at the neutral, but the live wire. Is that clear? Ken? Okay, since we have so much more time, before I go through the notes, let me just talk about D. Okay, so for a long time, we've been using a lot of fossil fuel. Okay, fossil fuel are non-renewable energy. Once you use up, it's gone for a long, long time, for millions of years. Okay, so and fossil fuel also produces a lot of greenhouse gases, okay, which is not healthy for Earth. Because fuel, to extract energy from fuel, you need to burn the fuel. So when you burn the fuel, Okay, you heat up the earth. Am I right? Am I right? Because you actually burn something, temperature goes up. You also produces byproduct like greenhouse gases like carbon dioxide and so on. Okay, so fossil fuel, first of all, is not renewable. Okay, and then it also produces a lot of greenhouse effect. Okay, so you actually make the earth hotter, and that's not a good thing, because as the earth temperatures goes up, the ice cap at our poles will melt, and as the ice cap melts, water sea level goes up. A lot of things happen now, so that's not good, and that is actually no good for Singapore as well, because Singapore is actually at sea level. So if water goes up by 2-3 meters, okay, a lot of our Singapore will be submerged. At the same time, okay, because we are also low-lying, there'll be also a lot of floods, because water from outside, once there's high tide, you actually flood the land. Okay, so we do not want our temperature to go up so fast. Okay, it's already going up since the industrial age. Industrial age is when they discover fossil fuel to create energy. Okay, so the temperature of our Earth has been going up at an accelerated rate. It may not seem like a lot every year, but over 100 years, okay, it actually went up by a few degrees Celsius already. Okay, if we continue at this rate, before your hit old age, will be in deep trouble. Okay, so we need to keep on looking for renewable energy sources like nuclear energy. Okay, nuclear energy sounds very dangerous. Yes, when not controlled, nuclear power plant will become like a bomb. Okay, you have a chain reaction that if it's not controlled, the energy produced will be at the exponential rate, and when that happens, it becomes like a bomb. Okay, you'll destroy too many things. So for nuclear energy, if you can actually control the chain reaction, okay, nuclear energy is actually a very clean energy. Okay, nuclear energy is very clean energy, as it does not really produce the side products like what fossil fuel produce. The only thing that nuclear energy you need to be careful is you need to make sure that the reaction is controlled, and then you're able to manage the waste that is produced by the nuclear energy. Other than that, it is a very clean source of energy, just like solar energy, just like wind energy, as well as hydro energy, okay, or even geothermal energy or wave energy. All these energy are very clean. Okay, it doesn't produce greenhouse gases. Okay, so for nuclear energy, if you go and read about it, it is also a very clean energy. But you must know how to control it. If you don't control, instead of being a power supplier, it can turn into a bomb. Okay, so we need to be very careful about nuclear energy. Okay, but nuclear energy so far has been pretty safe. Okay, pretty safe. But still dangerous, but still safe. Okay, next thing. We need to, okay, this one you go and read out the details in your textbook. Okay, we must make sure that in our at home, our electrical appliances, all our insulation, like the electrical cable, don't have a stray wire. Okay, you don't overload your power plug with many plug. Okay, when you overload too much, it heat up still okay. If it heat up too much, it may overheat and then start a fire. Okay, that will be very bad for your home. Okay, you don't want it to form a fire. Am I right? Okay, and also because electricity can also flow in water, you will not want, okay, you will not want your electrical appliances to be near any dam condition. Is that clear? Okay, therefore, if you look at all the new houses, other than water heater and the lights, you by right, you cannot install any electrical point inside your toilet or your bathroom. Okay, because if the condition is damp, it can be dangerous. Okay, you may ask me, why is it dangerous since water is not a metal? Yes, pure water is a non-metal. Pure water will not conduct electricity. However, water is a very good solvent. Okay, so things can dissolve in water to form ions, correct? You all learned that in chemistry. And the ions in the water will be able to conduct electricity. Okay, so for most of the water that we handle in real life, they are not pure water. Definitely there will be impurities. They may have salt in them. Okay, so water that has ion inside can conduct electricity. Okay, so therefore, please keep your electrical appliances away from water. Understand? At this point, if you are clear about what I say so far, can you give me a thumbs up? Ryan, are you okay? Are you there, Ryan? Okay, thank you, Ryan. Okay, let me just talk a bit more things about F, about the rest here. Okay, let me talk about what are fuses and circuit breaker? Okay, remember I told you there is always wire, live wire going into your appliances, and then it become neutral. This is always 0 volt. This one could be 230 volt. Okay, so you know that electrical appliances always have some resistance. Am I right? So current will flow into your appliances and then come out. Okay, so for every electrical appliances, there is an ideal amount of current you can fit into your appliances. If the current becomes too high, it may spoil or burn, or it may short your appliances. Am I right? Okay, is it clear so far? So my current cannot be too high. Okay, so that is where your fuse and circuit breaker comes in. Okay, remember I told you the last point here, all these things should be at the live wire. Okay, so I should put my switch here at my live wire, not at my neutral. Okay, so let me give an example. What happened if I put my switch at the neutral? Okay, what happened? Let me show you. Why is it dangerous if I put my switch at the neutral? Okay, so let me give an example. Why is it dangerous if I put a switch at the neutral? So can you see over here? If I open the switch, can you all tell me, can the appliance work? Tell me in the reaction, yes or no. Tell me in the reaction, yes or no. If I open the neutral, can this work? Okay, Pei Kwan, well done. Can it work? How about the rest of you? Only Pei Kwan, Oscar, correct? You think you tell me can work? The circuit is open, right? Can it work? Ryan and Chelsea, can this appliance work? You think can this work? Okay, let me just use another example. I use a light bulb. Okay, so can this light bulb light up when my switch is open? Okay, Chelsea, Yiting, and Ryan, can you tell me? Okay, it will not, because the circuit is open. There's no complete circuit. There's no closed circuit. The light bulb will not work. However, if I put the switch at the neutral, this whole thing is very dangerous. Why? Why? I'm going to highlight. Can you see here? The live point is 230 volt. So anywhere along this line, will have a potential of 230 volt. Is that clear? Any point here, you have a potential of 230 volt. Even though it will not light up, any point along this part here will all be 230 volt. If you put your finger here, what happens? If you put your finger anywhere along the highlighted place, you will get an electrical shock because your hand is 0 volt. Okay, there is a potential difference. Current will flow. It will flow through you. Okay, it's very dangerous. So are you clear why a switch should be at the, okay, the switch should be at the live wire and not the neutral wire. Are you clear about this? Okay, if you are clear, give me a clap. Okay, very good. Okay, let me just explain further. So I talked about the switch already. So now I'm going to talk about a fuse. Okay, the fuse you can put anywhere because what happens is, okay, let's say I have a fuse here. Okay, what does a fuse or circuit breaker does? A fuse or circuit breaker does is that when the current is above a certain value. Okay, for example, if I have a 13 ampere fuse, what does it mean is if the current goes above 13 ampere, okay, if this current goes above 13 ampere, this whole thing will break, and then then the whole circuit will be open. Is that clear? So same thing as a switch. If there is a break here, your light bulb is safe. You will not burst. Okay, because the light bulb maybe will burst at 20 ampere. So when the current becomes so high, become 50 ampere, before it reaches 20, your fuse will cut the current. Okay, so you actually protect your appliances from getting spoiled. Clear so far? However, if I put my fuse at the neutral, okay, if I put a fuse at neutral, okay, there's a cut here. Okay, there's a cut here. Okay, when there's a cut here, it breaks. The wire here breaks. Current will not flow through anymore. Your bulb is safe. Okay, it will not spoil. However, it's dangerous. Okay, it's dangerous at this point because, as I mentioned, it is still connected to the 230 volt power supply, the live wire. So even though there's no current going through, even though your light bulb is safe, okay, something goes wrong in the circuit, therefore the current becomes too high, but your light bulb is safe, but if your finger touch here, what happens? You'll get electrical shock as well. Understand so far? Okay, so therefore all your safety devices must be at the live wire. Okay, so your live wire, my fuse should be at the live wire. And this is my neutral. Neutral is usually 0 volt. Live is 230 volt. In Singapore, it's not DC, it's AC. So this value goes up and down at 230 volt. Clear? So if something goes wrong here, suddenly it draws a lot of current. When the current is higher than the rated fuse, the fuse will cut the current and your device is safe. So what happens when your fuse get blown? What happens, or your circuit breaker, it actually cuts the circuit. Okay, cut the circuit so the current does not go through. What do you do next? Can you tell me? When your fuse get broken or your circuit breaker trips, it doesn't allow electricity to flow through. What do you do next? Can you type it out in the chat? What do you do next? Do you replace the fuse? Do you reset the circuit breaker? Do you do that? So that it can on again? Type it out in the chat. Okay. Xiao Xing says disconnect and reset. So your appliances is still there, right? Bei Guan say find out what's the problem. Yu Ting say change the appliance. Okay, so what should you do? When let's say at home, there's a power trip. Okay, suddenly no light. And then you go to your circuit breaker at home, you see that one of the flip is actually tripped. Then what do you do? What do you do? Do you go and reset it immediately? Or if it's a fuse that is being burnt, do you go and buy a new fuse and then replace the fuse? Do you do that? You all know how a circuit breaker looks like or not? You want me to show you how a circuit breaker looks like? Let me show you. Show you my house. Can you see this thing here? This is a circuit breaker. Okay? Can you see now? I don't know whether is it bright or not. All my blue color circuit breaker here, they are all up. Can you see they're all up? When the thing trip, you'll be down. You push it up, back up, you will the current will flow through again. Okay, can you all see that? I know it's very dark, but can you all see? Okay. Now is it brighter now? Okay, not very. Okay, so this is a circuit breaker. Okay, at my house. Okay, they are all up. Can you all see they are all up? Okay, they are all up. Means they are all circuit is running through. Okay, if you all need to, you all may want to label what does all this mean. Okay, this is the main one. Can you see this? This is the main one. Main one. So this controls the whole electricity at my house. So when this one trip down, there'll be no electricity. I press it up for it to on. Okay, same thing. If I want the whole house to have no electricity, I press this down. So I can change my electrical power point, for example. Is that clear? Okay, so the thing is, if there is a trip, it tells you that something is not right. Okay, something is not right. When there is a trip, something is not right. Okay, so what you need to do by right is not to go and reset the trip. Okay, you're not going to reset the trip because you know something is not right, therefore the power trip. Is that clear? Okay, so if you know that something is not right, the power actually will trip. So you need to go and find out what caused the power to trip. Yes, you can still on it back. If nothing happened, fine. But if there's always something happen, you'll trip again and again and again and again because you want to protect your appliances. Okay, so when your whole house, the electricity keep on tripping, go and find an electrician to find out what caused it to trip again and again and again. Is that clear? Okay, so now that you all know, when the current is too high, a circuit breaker or a fuse will cut the current. So what's the difference between fuse and circuit breaker? Can you tell me? Because they both serve the same purpose, right? Why don't we just all use fuse? Or why don't we all use circuit breaker? So what are the difference between fuse and circuit breaker? Can you tell me? You type in the chat, share with everybody. Can you tell me what is the difference between fuse and circuit breaker? Okay, Yu Ting, can you share everybody? Okay, very good, all of you. Don't show to me. Okay, very good. So both of the fuse and the and the circuit breaker, they both serve the same purpose. But fuse is something very small. One, it is burnt, you need to replace it. Whereas for circuit breaker, you just need to flip the button back and then it can work again. Is that clear? Okay, Yuting asked me a question. What is the earth leakage circuit breaker? Where do you see this word? I'm also not very sure. Where do you see this term before? Okay, can you tell me more? Or maybe you say take a picture of your notes and show it to me. Can you tell me what the notes say? Okay, next thing I will talk about will be double insulation. Okay, in your electrical appliances, okay, a single layer of insulation will be enough. Okay, but you do double to have double the protection. Okay, so sometimes you want to make sure that you don't get electrical shock, you do double insulation. Okay, so that in case one insulation break, you are still protected. Okay, next thing is a lot of appliances have metal cases. Okay, have metal cases. So why is it dangerous if your appliances have metal cases? So for example, I talk about let's say a circuit. Inside got one bulb. Clear? And then this circuit is housed by a metal box. So the blue color is the metal box. If everything is insulated properly, you touch the metal box, nothing will happen. Is that clear? If everything is insulated properly, if you touch the metal box, nothing will happen. However, if something goes wrong, okay, if one of the wire inside here touch the metal casing right here, then this metal casing will be a dangerous thing to touch. Is that clear? Okay, so we have the live and the neutral. So to make your metal appliances safe, okay, if it's insulated properly, it's fine. But if it's not insulated properly, if inside of your equipment there's a short circuit or there's a wire that ends up touching the casing that's made of metal, your metal, okay, when you touch it, you'll feel electrical shock. Do you all actually experience before some appliances that has no earth wire? When you touch it, you feel a bit of shock. Okay, that is because it doesn't come with an electrical shock. So to prevent that from happening, you need to earth the metal case. Okay, so you need to connect certain earth wire to the metal case so that your metal case will not give you an electrical shock. Okay, so in your electrical appliances, this is your earth wire. Okay, so in a 3-pin plug, okay, in your mains plug, 3-pin plug, there are some appliances that has only 2 plugs. If it's only 2 plugs, you'll be live and neutral. And usually these appliances does not have a metal body. Usually it's a plastic body or something like that. However, if it's a 2-pin plug and then it's connected with a metal body, you go and try. One day you go and touch, you'll feel a bit of shock because the metal casing is not earth. Is that clear? Okay, so to prevent yourself getting shocked, you make sure that your appliances has a connection, the metal body is connected to the earth wire and the earth wire is connected to the ground. And that is why for Singapore, a lot of our appliances has 3-pin. In other country, maybe 2-pin. So if you have a metal casing, sometimes when you touch it, okay, for example, I give an example, like my laptop. My laptop made a metal body, correct? And then if your charger is only 2-pin plug, and sometimes you feel you touch your laptop, you get shocked. Okay, because something happened inside the laptop, there is a short circuit or what, there is a leakage. Then when you touch the metal body, you get shocked. However, if your charger is a 3-pin plug, okay, even if your computer is made of metal, you will not get shocked. But once you feel shocked, it means something is not right. You go and get someone to go and check it out. Means that there's some short circuit inside the board, inside your component, or there is some wire, stray wire touching your casing. Therefore, you can feel the electrical shock. Is that clear? So, up to here, any question for me? Do you all find it useful? Okay, I'm just using the syllabus to explain to you. I did not show you any picture. Okay, maybe I show you some picture lah. Then it'll be easier for you to understand. You give me a moment. So next week we're going to do practice question. So a lot of things I want you going to read out yourself, especially the safety part. Because the safety part will be the part where there's a lot of facts. Okay, I don't like to go through facts. Doesn't mean it's not important. When it's a factual stuff, all you need to do is just go and read out and remember. Okay, so most of physics don't need to remember things, just understand will do. Okay, but for some of this topic, some of the things in this topic you need to remember. Clear? Okay, so let me just go through quickly about this, then we end the lesson. Okay, so electricity, just remember as one small part about this topic is electricity can be used for heating effect. Okay, there are a lot of heating devices like kettle, like iron, like this one radiator, or even your hot plate. Okay, all of these uses electrical energy to convert to thermal energy. So these are just some examples. Okay, remember one of the topic that you need to know, how electricity can be used for heating effect. Okay, so I mentioned about the 3P formula and the 3E formula. So this will be my exit question. Later you're going to tell me. And also calculated, 1 kilowatt hour is how much joule, which is 3.6 megajoule. Okay, y'all actually know about this. Okay, now the next part. Electrical energy, we talk about the non-renewable energy like fossil fuel. Okay, so now we talk about some renewable energy. I'm not going to talk much about it. I give you 20 seconds. You can take a picture or you're going to watch the video later on. Hey, Yuting, you just message me. Let me see what you sent me. Okay, I roughly understand what you mean by this. Okay, have you all taken a picture? I will not go through this. These are just telling you what are the pro and con of solar energy and what is the cost of it. Okay, so I'll just go through a bit more. They have hydroelectric energy as well as wind energy. Okay, you all can take a picture of this. I will not go through this. You're going to read yourself. Yeah, you're done? Okay, E.T. asked me a question and then she sent me her notes. She asked me, what is a earth leakage circuit breaker? Okay, let me just explain to you a bit. Okay, to be honest, I don't know. I just Googled the answer. Okay, but basically, circuit breaker and fuse, they work the same way. If the current is too high, it will cut off the current. Okay, so far, you think? Okay, and circuit breaker, there are many, many types. Okay, the one that I show you at my house, okay, that one is not a earth leakage circuit breaker. That one is called a RCCB, which stands for residual current circuit breaker. Okay, so the modern houses now uses RCCB. Then ELCB, earth leakage circuit breaker, is a little bit older. Okay, so for you don't need to know the type of circuit breaker. There are many types. There are ELCB, there's RCCB, there's MCB, there's MCCB. There's a lot of CB. I'm not scolding you like that. Okay, so there's a lot of circuit breaker. All you need to know is that circuit breaker, the function is to cut the the current when the current is too high. Okay, that's all you need to know. Okay, you think? And from your notes, you also show the same thing. It also just tell you that the circuit breaker will cut when the current is too high. So there are many types of circuit breaker. Earth leakage circuit breaker is one of the many. Okay? All right. So there are also non-renewable energy. Okay, so can you take a picture of this? Nuclear energy and fossil fuel. They are both non-renewable, but for nuclear, it is a clean energy. Okay, it doesn't produce air pollution. Whereas for fossil fuel, it produces a lot of air pollution. You think you understand about the ECCB already? Sorry, ELCB already? Okay, don't care about the term. Just remember that the circuit breaker is just a circuit breaker. That's all you need to know. Okay, so you're going to read this up yourself. Okay, so same thing for this part. Go and read yourself. Okay, take a picture if you want, or take a screenshot. Go and read yourself about dangers of electricity. Okay, I'm not going to go through this. Exam, when they ask you, it's just straightforward. Just write down what you learn here. Okay? I'll give you about 30 seconds to take a picture of this page. Yeah, you think your second page of your notes, right? They talk to you about another type of circuit breaker, the miniature circuit breaker. So the individual that you see in my circuit breaker, the small, every single one, that's a miniature one. Then the whole thing is called the RCCB. Okay, there's a lot of types. So just don't need to remember all types. Just remember circuit breaker. Can you think? Okay, so this page, okay. So safety feature of a home circuit. Okay, so the other thing that you need to know in your plug, there are 3 wires. Okay, usually the wires are red or brown, blue or yellow, green or green. How to remember? Okay, just remember that earth is green. Okay, can you remember that? Earth is green. Then live wire is the most dangerous. Most dangerous, it is very close to red. So when you see a brown or red color, it is connected to the live, it is a live wire. Is that clear? Neutral wire is a neutral color blue. It is connected to the 0 volt of the power supply. And can you see over here? All these 3 features are all connected to the live wire. Okay, not the neutral wire and not the earth wire. Is that clear? Then the last part here. Last part, earthing. When your appliances has a metal casing, okay, large current can flow to the ground through the earth wire, okay, so that when you touch the metal casing, you will not get electrical shock. Okay. So for 3-pin plug, one of them has the earth wire. Okay, some of your appliances have only 2-pin plug. And for a plug itself, it always have a fuse. Okay, so this fuse will burn when your current goes too high. And lastly, when I talk to you about the double insulation, if your electrical appliances has this symbol of 2 box or the Chinese character of Hui, okay, it means that your appliances are all insulated, okay, 2 times. Is that clear? Okay, so when you see things like this, it means that your appliances actually is safer to use. Okay, so any question for this topic? Okay, a lot of the things in this topic are facts. Okay, I need you all to go and read and remember. Okay, and I believe that this topic, most of you have already learned in school already, because I'm actually slower. So first, so I got 2 checkout questions for you. Number 1, how much have I value add to you for this topic? Okay. Number 2, give me the 3P and the 3E formulas. Okay. Once I call your name, you may leave the class. And next week, we'll go through the sample question. Okay, so for question 1, if I value add you a lot, give me a rating of 10. If I did not value add, give me a rating of 0. So Xiao say you did not learn much. You didn't learn everything. What I said today, you didn't learn a lot. Okay, Xiao say you may go. Ryan, you learn a lot. You never listen in class. Okay, so Ryan, let me see your formula. Ryan, you may go. Oscar, your rating so high. You don't understand what you learn in school, or am I too good? Okay, you think? Oscar, you don't make me happy there. You don't show me your result. Can you show me good result, please? Okay, Oscar, you may go. You think your formulas are okay? You may go. Hooray, you may go. Bei Kwan, you may go. Anybody got any more questions? You can stay back to ask me. Thank you so much. Good night. Goodbye.